Hello, Padres. Welcome to our next Ed puzzle. For this one, we're going to be looking at motion notes. The slide deck will be also on Google Classroom, so if you want to follow along with the slides, you can later. I do recommend you take notes and write this down. Whether you want to do that now in your notebooks and pause it as you go along, that's up to you. Or you can just sit back and listen, go to class, and that might clear things up a little bit. And you can come back and watch it a second time and take notes the second time. Whichever way works best for you, I want you to do it. Also, I'm going to be stopping this Ed puzzle a few times and asking you some questions. They are worth 0 points. You will get full credit as long as you watch the whole Ed puzzle. So if you get questions wrong, you will not be penalized ever for any Ed puzzle that I give. So without further ado, here we go. The first thing we're going to talk about is the difference between a scalar and a vector. So a scalar is a quantity that has only size. So an example of this would be like age. If I said I'm 22 years old, that just has a size to it. Or I could say I'm 50 years old, which would mean it's a bigger size, but it doesn't give you any extra information other than size. So here are some things that also are scalars: height, temperature, distance, time, speed. They only have a magnitude component to them. Versus a vector. Vectors have size, but they also have a direction with them. And we're going to mostly be dealing with vectors in physics because vectors give us more information. They don't give us only the magnitude, but they give us that direction, which is important. So an example of this might be like if I push something, I can push it this way, or I could push it this way. I could push it up or down or east or west. All those have descriptors that are giving you more information about the direction the force is being applied. So that would be an example of a vector. Other vectors we're going to talk about are displacement, velocity, and acceleration. So we'll talk about those actually soon. Distance. Distance has the symbol d. It measures how far something travels. It can either be a length or a height. And it is measured in meters. So something is 2 meters or 4 meters. It's a scalar, so it doesn't give us anything other than the distance. All right. And we can use a ruler or a measuring tape to measure distance. Displacement is similar to distance, but it's a little different. So displacement, we use the symbol delta x, and it is the shortest distance between the initial and final position. So delta, you may know, is this triangle. It means change, and x is position. So it's really measuring the change in position. So the change in position, if I say between here and here, what's the change in position? You just measure the distance between the 2 points. But if I say here to here, there is not only a distance, but there is a direction. It went from this point to this point, or from this point to this point. There's a direction to it. So it's not just the distance we're measuring, but we have that added piece of the direction it's moving from the first point to the end point. So that makes it a vector quantity. And it's also measured in meters, but there's going to be a direction usually attached to it. The direction could be east or west or up or down, like I mentioned. It could be a positive or a negative, like on a number line. Right is usually positive, left is negative, and up and down. Up is positive and down is negative on a number line. So we have these descriptors that kind of give us more information. And we would measure them the exact same way as we would a distance. It just has that added directional component to it. So here we have a little green man. The little green man follows a little green pathway. And you can see the difference between distance and displacement. Distance would be the total length that he walks. So the distance could be very long. The displacement has a direction to it. He started here, he ends here. It is a straight line. It has an arrow, and you can see it has a direction. You would either say it's southeast would be the direction, or for honors, we may be measuring the angles of some of these to get the direction off of the x-axis, for example. So you can see the difference, distance versus displacement. So let's look at this example. This roller skater goes from point A to point B to point C. What is the distance? Take a guess. Not worth any points, but just take a guess if you get it right. The answer is 7. A to B to C, the distance would be 4 plus 3 would be 7 meters. What do you think the displacement is? Once again, worth no points. Take a guess. You are correct if you said 5, because it is the shortest distance. If she starts at A and ends at C, it would be going at this direction, 5, and you would also say 5 southeast or 5 with an angle. Once again, for honors, we might be measuring the angles of these in the future. Let's do another example. This boy walks from point A to point B to point C to point D. So A to B to C to D, and then back to A. What is the distance? Take a guess. Did you say 16? 3 plus 5 is 8, plus 3, 8 plus 3 is 11, and 11 plus 5 is 16. What would be the displacement? The displacement is 0, because he started at point A, he ends at point A. What's the distance between point A and point A? 0. All right, hopefully you got that. Let's move on to time. Time, we're going to use the lowercase letter t, and time measures how long it takes for something to happen. And we're going to be measuring it in seconds. You will see it either written as an S. If I'm writing it on the board, I'll write an SEC, just because sometimes my 5s look like S's and my S's look like 5s. And if I'm writing it on the board, I don't want you to get mixed up between them. So you'll either see it as an S if it's typed, or if it's written, sometimes I'll write it out just to make it more clear. And you guys know what we measure time with. Speed. Speed is how fast something is going. It's in meters per second, is what we're mostly going to be measuring it in. It is a scalar. It only tells us the size of it, the magnitude. If you look at your speedometer on your car, it tells you you're going 65 miles an hour, period. No more information is given other than 65 miles an hour. And in fact, if you put it in reverse, the speedometer tells you the same thing. It'll tell you how fast you're going. Velocity is a little different. So velocity is the speed, but velocity gives us a direction. So just like distance and displacement, speed and velocity are very similar, except they have that, one's a vector and they have that direction component. So with velocity, usually mathematically, if something is going right or up, we say it's positive, just like on a number line, right? Right or up is positive, and down or left would be negative. And once we start doing some math problems with that and you see how they're positive and negative, I think it'll make much more sense. And so speed and velocity, the cheetahs have a high speed. They also have a high velocity. And acceleration. Acceleration is A. It is a change in velocity in a given time. So mathematically, we'd write that as A equals a change in velocity, delta V, divided by a time, a change in time, delta T. It's measured in meters per second squared. It is also a vector because velocity is a vector, acceleration will be a vector. And importantly, it measures how much velocity is changing every second. So how much is this velocity changing per second? That's what we're looking at. And A lot of people get this one wrong on the test. So if you have a highlighter, I would highlight it, circle it, put some stars next to it. Glitter, if you got glitter, awesome. Throw some glitter all over that puppy. Acceleration happens when things speed up or slow down. So if you're at a stoplight, light turns green, you step on the gas, you are accelerating. There is a change in velocity. If you slow down, you slam on the brakes. There is also a change in velocity in the negative direction. So you would have a negative acceleration. But the part that people most often miss is that it also happens if you change direction. And that is because velocity is speed and direction. So if the speed changes, the acceleration changes, or there is an acceleration. If the direction of the velocity changes, the velocity changed. So you'll also have an acceleration. So acceleration happens when things speed up, slow down, or change direction. Let's look at an example, and this is the last thing we're going to talk about today. Let's say you're at a red light in your car. It's time 0. You're at a red light. Your velocity is 0, and there's no acceleration. Light turns green. 1 second later, you are now going 10 meters per second. What would be your acceleration? So remember, acceleration is measuring how much the velocity is changing every second. So how much did the velocity change in this second? It changed 10, went from 0 to 10. So our acceleration is 10. For the second, we are now going 15 meters per second. What is the acceleration? Remember, acceleration is how much the velocity is changing every second. So how much did it change this second? Our acceleration is 5. In the third second, we're now going 12. What was the change in velocity? The change in velocity is -3. This one, fourth second, our change in velocity from 12 to 19 is 7. And I'd like you to answer the last one. What is the acceleration during the 5th second? Once again, worth no points. Give it a shot. Did you say -9? If so, awesome job. So in class, we are going to go over this. If you have any questions right now, please jot them down so you'll remember them, so we can make sure we clear all those up. And we're also going to be dealing with some of the math for this in class Monday. So see you guys soon.